Now we're going to talk about polygons and motion. Parallelograms, polygons and motion, parallelograms. You're here in your notes. Please make note of both the date and the location that you are watching this video, as well as the date and time. You can be looking at the CK12 textbook, pages 284 to 290 for future reference. As a quick review of our previous lesson, we need to work with these 7 key phrases or words when you're working with angles and polygons. Those key phrases are sum, interior, exterior, regular, each or one. You need to note what the number of sides are, or the polygon number. And the last is, are, was, were, which are all equal signs. Go ahead and write down those important buzzwords. Now let's finger track and read the problem here, underlining the buzzwords as you see them. It says a single interior angle of a regular polygon measures 108 degrees. What is the polygon called? So we have here the interior. We know it's regular. And notice it's using the generic name polygon, which means at this moment we don't know whether it's a pentagon, a heptagon, a hexagon, or a decagon. So that, when we want something to be called, what we're asking here is what is the number of sides? Because we call polygons by their number of sides. I want you to take a moment and attempt to solve this problem on your own. When you are finished, hit play, come back and check your work. All right, let's see what we can do here. It says a single interior angle of a regular polygon measures 108 degrees. Well, we know the equation for each interior angle, when it's regular, is sum over the number of sides. Well, in this case, we don't know what each interior angle, what we know is that we have a single angle is 108 degrees. Our sum, we don't know the n, so it's n minus 2 times 180, but we do know it measures 108 degrees. So what we're doing here is we're solving for n. So from here, we put this over 1. We're going to cross multiply. So we get 108 times n equals n minus 2 times 180. We want to get n on the same side here. So in this case, I'm going to distribute. And my next line reads 108n equals 180n minus 360. I'm going to minus 180 here, n minus 180, n. And I'm going to get here 108 from 180 is going to be negative 72n equals negative 360. I can see here the negatives cancel, so I'm just going to erase them. So to solve, I'm going to divide by 72. I'm going to do 360 divided by 72, and we get 5. So the number of sides is 5, which means it's going to be called a pentagon. A pentagon. Penta meaning 5. For the next couple lessons, we're going to be focusing in on quadrilaterals. Focusing in on quadrilaterals, four-sided shapes. The most important being a parallelogram. So let me introduce you to the four-sided shapes that you need to be familiar with. The first four-sided shape here that you need to be familiar with is this shape, which is called a trapezoid. Trapezoid. And then you have the parallelogram. And then all equal sides. There's usually two names. There's a technical and then a non-technical name. The technical name here is rhombus. You guys might recognize it as a diamond. Rhombus or a diamond. Again, what are these? They're four-sided shapes. We have a rectangle, and of course a square. And believe it or not, the shape kite, yes, that's an object you fly in the air, but it actually has a specific meaning. This is what's called a kite shape in geometry. I'll be more specific about what constitutes a kite shape in a later lesson. But these are what we would call part of the family of quads, also known as the quad family tree. We're going to be filling this page out for this lesson, so keep this page handy. We're going to be rotating it. So this looks more like a family tree. So let's start with your basic quad. Your basic quad is a four-sided shape. So under basic quad, we have a shape which has four sides. And if it has four sides, to find the sum of the interior angle, we do 4 minus 2 times 180. That's 2 times 180, which gives us 360. So we know in a quadrilateral, regardless of its shape, the angles are going to sum 360 degrees. Now in our quad family tree, these are the members of the quad family tree. We have the parallelogram, the rectangle, the rhombus, the square. Wait for you to catch up and get those labeled. Then on this side we have the trapezoid. And then a descendant of the trapezoid would be an isosceles trapezoid. And of course, kite. So you can see this creates like a tree. Some of these shapes are related to each other. We can see going this way that the parallelogram, the descendants of the parallelogram are the rectangle and the rhombus. And the rectangle and the rhombus both feed into a square. So technically, all four of these shapes here on the left, all four of them are parallelograms. They all share the qualities of a parallelogram. A rectangle, a rhombus, and a square are a specific type of a parallelogram. So obviously, a parallelogram is really important. So we're going to focus in just on a parallelogram for this lesson. So once again, for our basic quad, it was 4 sides, and we know that the angles sum 360 degrees. Now, a parallelogram has several specific qualities. The first and foremost definition of a parallelogram is sides are parallel, hence the name parallelogram. So I'd like you to trace these two sides. Put in the little arrow feathers. That means those sides are parallel. And I'd like you to trace these two sides. Little arrow feathers. So that is the most essential definition of a parallelogram, is the fact that your opposite sides are going to be parallel. Hence the name parallelogram. Parallelogram. Opposite sides which are parallel. So a parallelogram has opposite sides that are parallel. Now, because you have two sets of opposite parallel sides, it creates some other qualities, specifically 5 of them. So here's part of our quad family tree, and the 5 are going to be step number 1, we know that a parallelogram has 4 sides and angles which sum 360 degrees. Why? Because parallelogram is a descendant of a quad, and all quads have those 2 characteristics. Now, what makes a parallelogram specifically a parallelogram are these very important 5 qualities. And they are: 1, opposite sides which are parallel. Opposite sides which are parallel. So that means opposite sides which are parallel. I'm going to put the little arrow feathers in there. Number 2, opposite sides are also congruent. So opposite sides have the same length. Three, another opposite. Opposite angles are also congruent. So angles that are across from each other are congruent. So I'm going to do double sweep and single sweep. So the angles that are across from each other are congruent to each other. Opposite angles are congruent. The next one is consecutive angles are supplementary. Remember, supplementary means to add up to 180. Consecutive angles means angles that are next to each other. Angles that are next to. Consecutive means on the same side. So, for example, this angle and this angle are going to add up to 180 here. So angles which are next to each other add up to 180. And the last one is the diagonals bisect each other. The diagonals bisect each other. So if we draw in the diagonals, they're going to cut each other in half. In other words, that point is going to be the midpoint both ways. So hatch marks there, double hatch marks there. They do not all share the same hatch marks all the way around because you have one longer and one shorter diagonal. But they do cut each other in half, which means they go through each other's midpoints. A quick way to remember these, think OCD. Opposite, 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 consecutive, diagonal. Opposite, 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 consecutive, diagonal. Say it with me. Opposite, 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 consecutive, diagonal. Again, opposite, 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 consecutive, diagonal. OCD. Opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals bisect each other. Knowing these qualities, let's see what we can find. So we're told that WAVE is a parallelogram. Find the measure of all possible angles. So I'm going to do this, our little shortcut here, OCD. And these two specifically talk about angles. The third one is opposite angles are congruent. We also know that consecutive angles are supplementary. So these two have to do specifically with angles. So let's see what we can do here. Well, we know that here, if this is 84, opposite angles must be congruent. So that must also be 84 degrees. So I'm going to put a little 84 there, which means if I want to find this angle right there, I'm going to do 84 minus 41. And we get 43. So this right here is going to be 43 degrees. Now remember, we know that opposite sides are parallel. So opposite sides parallel. That means we can find armpits of the Z. Whenever you have parallel lines, we're going to go ahead and draw our first armpit of the Z. And we see here, if this is 41, that this angle right here must also be 41. So this angle right here is 41. We also have armpits of the Z going this way because these sides are also parallel. So we can go like this, which means right here, if this was 43, this angle right here must be 43. Let's see what else we can find. We know that consecutive angles are supplementary. Consecutive angles, that means angles that are next to each other. So in this case, if this whole angle is 84, this whole angle must be 180 minus 84. So we're going to go 180 minus 84, and of course that's going to give us 96. So this whole angle right here is 96 degrees. Which means this angle over here, this whole one here, also must be 96 degrees. Let's see what else we can find. If that's 95, let's pull this triangle out right here. This right here is 95 degrees. We found earlier this is 43, so we're going to find this angle now. We're going to go 95 plus 43. We get 138. We're going to take that away from 180. And we get 42. So this angle here is 42. We noticed this whole thing is 96. So I'm going to go 96 minus 42, and that'll give us 54. So this angle right here is 54. Again, we have armpits of the Z going on here, like so. Trace with me. So if that's 54, this angle here must be 54 as well, which forces this to also be 42. Now in the middle, this right here is 180. So to find this angle, we're going to go 180 minus 95. We get 85. So this is 85, which makes this 85, which makes that 95. So just knowing that this is a parallelogram, we were able to find every single angle in the diagram based on these three properties. Opposite sides being parallel, which gives us armpits of the Z to work with, going both ways, like so. It also gives us opposite angles, which are congruent, and consecutive angles, which are supplementary. Let's try another problem. It says, below is a parallelogram, solve for all the variables. Remember, it is O, C, D. We're dealing with sides here, so these specific one, opposite sides are parallel, and opposite sides are congruent. So if opposite sides are congruent, our first set here, we can do 6 equals 5r plus 1. Go ahead and solve. So we're going to get r equals 1 here, which is 5 times 1 plus 1 is 6. There's our check. Opposite sides are equal. So our first variable is r equals 1. Let's try this way. We know opposite sides are equal. So again, let's come over here. We have 4s plus 5 equals 6s. S, not x. Plus 1. We're going to minus 4s. Minus 1. These cancel. These cancel. We end up with 4 equals 2s, and s equals 2. Let's check here. 6 times 2 is 12, plus 1 is 13. 4 times 2 is 8, plus 5 is also 13. So s does equal 2. Let's take a look at number 3. It says, below is a parallelogram, solve for all variables. Solve for all variables. Remember, we have O, C, D. And the couple things that we know specifically about angles is we know that opposite angles are congruent and consecutive angles are supplementary. So let's see what we can do with the two of those. Well, we can't use opposite angles. Well, we can. Let's see what we can do. We have 125 and 5h. These would be opposite angles. And we know that they're congruent. So we're going to go 5h equals 125. So we can solve for h there, and we find h is 25. Now, we can't go this way and make these two equal because we're going to end up with two variables. So instead, we're going to take it this way. Consecutive angles. Consecutive angles add up to 180. So I can do this. 125 plus 7k minus 1 equals 180. We're going to collect like terms. And we end up with 7k plus 124 equals 180. Minus 124. 7k equals 180 minus 124, 56. And of course, in this case, k equals 56 divided by 7, which is 8. So we have two variables now. And our last one, these add up to 180 as well. So we're going to come in the margin here. And I'm going to have 11j plus 125 equals 180. So subtract 125 from each, so I have 11j equals 55. Divide by 11, and j equals, in this case, 5. So h equals 25, k equals 8, and j equals 5. Okay, last concept here. We're told ABC is a parallelogram. How do we know that triangle, let's trace it, ADB, so we go ADB, triangle is congruent to triangle CBD. So here we have CBD. It's asking why are the triangles equal? This is actually going back from the first semester. Remember, there are 4 ways triangles can be equal, and they are side, 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 angle, angle, and angle, angle, side. Now, what we know about parallelograms is OCD. We know opposite sides are equal, so I can go like this, plus the reflexive. So I could get side, side, side. I also know that opposite sides are parallel, which would give me these angles equal because of armpits of the Z. And that would actually give me both side, angle, angle, or angle, angle, side. So when you're given a parallelogram, any 4 of these would work. Now, what I'd like you to do is choose one of these and write an explanation. I want you to cite which sides are congruent, why, and which angles are congruent. and y. Be specific, one of those four. All four do work. You must choose one and write your explanation.